You people are way too awake for 9 a.m. in the morning. Is this just a Swedish thing? Because if I hold 9 a.m. meetings in Redmond, no one turns up. In fact, if I hold 10 a.m. or 11 a.m. meetings in Redmond, I'll be lucky if someone turns up to the 11 a.m. one. Good morning. My name is Barry Dorrance. I am the .NET Security PM, which makes me a very grumpy person because I look after security for all of .NET and own certain features like authentication and authorization, which I'm going to hopefully get through today in 50 minutes. This may be a bit of a tight squeeze. The organizers asked me for a brand new presentation, so you are guinea pigs. I can get through it in 50 minutes on my own when I rehearse, but it's always kind of different when you're in front of an audience. So this is mostly going to be code. The slides will have the code on it to remind me what the heck I was supposed to be pointing out in Visual Studio, but you don't have to pay that much attention to them. But you can grab them later on. I'll shove them on my website. So, authentication, the act of knowing who someone is. How many of you are using .NET Core? Why are you here then? You should know this stuff. So what I am going to do, which hopefully will help you understand why things are laid out the way they are, is I'm going to go through external providers, I'll go through cookie authentication, then I'll talk about cookie validation, claims transformation, and then, because people keep asking me about it and we haven't documented it because we don't want you to do it, I'm going to talk about writing your own authentication handler. I am so nervous about this because I seriously don't want people to do it. I've asked people a few times, give me a valid reason why you've written your own handler. One person came back with your Swedish bank ID, which is fair enough. If you're going to use different standards to the rest of the world, I guess you need your own handler. Other people have wanted to write handlers for integration testing, where they want to do things like put a username in a query string. And I just hope that that gets ripped out of the final compiled code. So I'm going to show you the query string example. We'll cover authorization in a bit. So how many of you are still on .NET 1? .NET Core 1? Are we all on 2? Oh, that's marvelous. Okay, so in 1 we basically revamped all of authentication and authorization because it was horrible and bad. And we provided support for multiple providers from the beginning. And in .NET 1.0 and 1.1, it was a little bit badly designed. You could add multiple providers. You could have cookies. You could have JOT. You could have well, you couldn't have WSFed because that's in 2. You could have Facebook. You could have Google. You could have them all at the same time. And then you could select which one you wanted to use during your authorization stage and do all sorts of fun stuff. And you could choose a default, one that would run on every single request. And the way you did that was you set a property on the authentication provider that said this is the active one. But because that was an individual flag in every single provider, people set that flag on more than one, which got you into what we would politely describe as an unsupported scenario, which basically boils down to we have no idea what's going to happen, we don't care, we're not supporting you, because that's not what you're meant to do. However, the API let you do it, which proves that the API was bad. So in 2.0, we changed things. Authentication is now a single service. The single service holds one or more authentication handlers, and each authentication handler has has a property that's a scheme. And that scheme is just a string. It is the lookup for that scheme that you use when you're selecting schemes in authorization or trying to configure stuff. So we'll set this up, and I will publish the projects later on. Set a startup project. Let's unpin that so we have a little bit more space. So first off, in services, I'm adding the authentication service, and I'm setting a bunch of options on it. I have the default authenticate scheme, the default sign-in scheme, and the default challenge scheme, and we'll come on to what those mean in a bit. The default authenticate scheme, I'm setting to cookies. The default sign-in scheme, I'm setting to cookies. And the challenge scheme, I'm going to set to Facebook. And then I add the cookie authentication bits, the handler. I add the Facebook and configure it so it has my app ID and my app secret. And then the bit that I always forget, it's inside configure. I do app.use authentication. You forget that stage, you can configure everything correctly, nothing will work. So if I run it, it won't show you much. It will just eventually bring up a browser, log in, and come back again. I'm doing this just as raw Kestrel because IIS is a little bit interesting and can change host headers on me or host ports from non-static values. So if I stick it in Kestrel, I'm going to have static values and it'll work when you download the GitHub repo. So what this has done is it's logged me in through Facebook. I've already authorized the app, so it will it doesn't have to prompt me, and it will come back to hello Barry Dorrance, and I have no idea what Facebook is doing here. I think that's because Facebook eventually want to move to putting access tokens in query strings, and so this is a nod to it, and then they went, wait, that's not an OIDC login within an app, within a constricted web browser, so I'm just going to do this. So I've logged in, and we can see that there's a little bit of debug information that's not very exciting, but we can see that it bounced off to Facebook. Facebook was challenged, it goes to Facebook, and then a request comes back in from Facebook that is this. And we decode it, and I rip out from the Facebook information that I'm me. That's all very exciting. And just to prove that I am not cheating, we will look in, well, we look a bit further down. I don't even have any views. I'm just going to, if I am authenticated, if I'm not authenticated, I'm going to call challenge, which is what kicks off the Facebook auth dance. If I am authenticated, I'm just going to spit out hello and the name from the current user property, the current user's identity property. This assumes there is only one identity, which may not always be the case. So, nice and simple. So like I say, the code is just here to remind me that I've covered everything. So each handler has a bunch of events. I mean, what we've done is just a simple login, and that works if you want to be horrendously GDPR compliant and never want to store any personal information, which would be great, but most people's business models are not built like that. That may change as Europe issues large fines. I read yesterday that Europe has fined Google more this year than Google paid in taxes. Yay, GDPR, and those pop-ups that I don't see when I'm in the US and I have seen every day this week. So most of the stuff that you want to do is, let's face it, you either use ASP.NET Identity, let us do the hard work for you, or you go to Azure AD or Azure AD B2C or Auth0, or you do social login. The social login stuff is a little bit more interesting because when you do that sort of login, it's usually done by OAuth or OIDC, and we'll eventually move the Google stuff to OIDC because they're shutting their old endpoints down. And you want something more useful because you will get access tokens back from Facebook. And so you may want to yank the access token pieces back. And the way you do that is you hook into the OAuth or the OIDC events. If you are overwriting these things, there are a couple of things to be wary of. The on redirect to authorization endpoint, when you start overriding them, there's no base that you call. So you need to do the redirect yourself. And the way you work out how to do that is you go to the source and you look at the source, which is incredibly useful. But on creating ticket is the one that you're normally going to hook into, and that allows you to look at the response that's come back from the ID provider and pull things out of it. In this case, I'm going to pull out an access token. So we swap back. So I'm going to add a bunch of options here. I'm going to hook into every single event and inject a bunch of log information. So we're cheating, sorry, we're not cheating, but we're adding the log information now by changing the startup constructor. So it takes an instance of iLogger factory, and this is how you log within startup. I'm going to save it. I'm going to create one and save it away here, and then I've got the logger available to me throughout my entire startup for demo purposes or for actually doing something useful in your own code. So we have on redirect to authorization. So this is when I tell Facebook to do the authorization dance. It's going to fire it over to Facebook. And like I said, you have to put that in, otherwise nothing happens. On creating ticket, I'm going to look at the identity that has been created by the Facebook handler, and I'm going to pull bits out of it. There's context.access token, there's context.refresh token as well, so you can save those things away in a database securely in a way that won't leak because they're PII and the GDPR people will get you. On ticket received, I'm just going to log, and on remote failure, I'm just going to log. So if I run this, oh, and then what I'm going to do at the bottom, rather than print out the access token, because that would be a dumb thing to do, I'm just going to say, hey, yes, I have one. I'm going to look in my claims identity. I'm going to look for a claim that matches the claim name that I have added if an access token is available. And if it's there, I'm going to write it out. Or well, I'm going to write something out saying, yes, I've got one of these. So we're going to see a little bit more logging information. But it's the console. So the console logging is really hard to parse as you watch it. But we'll see things. So it's gone through its authentication dance, and this time, because in the events I have yanked out the access token and shoved it in the identity, it has persisted all the way through to the point where I'm doing output. So we'll go back here and we'll look at what happened. So we have got our initial requests. We are going to redirect. We've got Facebook being challenged, and like I say, this is just really hard to see. But look, here we go. We've got creating tickets, tickets received, and then cookies signed in, and so on and so forth. So nothing really looks different apart from the extra log stuff, I hope. But this means that we can basically just hook into what we want. Okay, go away, you. So why is cookie auth needed at this point? Well, Facebook auth just authenticates through Facebook. It doesn't save anything. Cookie authentication is the best way to serialize user's identity to a user's browser and then rehydrate it on the way back again in a web environment. If you're doing an API environment, you'd stick it in a JWT token and you'd have your application store it in browser local storage or something of that sort. But for normal web applications, we need cookie authentication because it's persistent. There are a few types of persistent authentication. There's cookies, there's certificate authentication and basic authentication, neither of which we provide in .NET Core. Instead, I wrote them and they sit in my repo. Cookie authentication will likely make it into 3 because there are apparently European banking standards that want it. Still, basic authentication will never make it in because it's a horrible, bad thing, even though people use it on the back end for stuff, but we are not supporting that. And then there's remote authentication. It's all the social stuff that bounces through things, or Azure Active Directory or Azure Active Directory B2C. And when the social stuff comes back, when the remote stuff comes back, it doesn't save anything. So I've got to take that identity, I've got to shove it into cookies, and then cookies is what gets persisted on every request, and then in every request that comes back, we will look for cookies, and if there is a valid identity cookie there, we will check its signature, we will decrypt it, and then we will take the claims that are embedded within it, and we will rehydrate an identity with it. So all those defaults are a little bit overwhelming, which is why I have a wall of text. Yay! Default scheme. Default scheme is when you're using cookies and cookies alone, or you're writing a web API project and you only care about job. So you just said default scheme is basically, I'm going to handle everything that comes down here. The other reason I have a wall of text is so I can remember all of this. The authentication scheme is the authentication handler that runs on every single request. So if it's cookie, when a request comes in, the cookie authentication handler is asked to authenticate. It will go away, it will look at the request that's coming in, it will look for a cookie, and then it will do the whole thing to create the identity and shove it on the request so it's available everywhere else. Challenge is, well, it's challenges. So if authorization has been required, but there is no identity, we challenge for an identity. Forbidden is authorization has been required, but the current user doesn't match the requirements. So they're forbidden from doing what they're doing. We don't prompt for another login. Generally, by default, we just tell them that they're being naughty and they shouldn't be doing what they're being doing. And default sign-in and sign-out schemes are optional. They indicate whether something can actually perform a sign-in and a sign-out. So cookie authentication with ASP.NET Identity generally can perform a sign-in and a sign-out. JWT authentication cannot. JWT authentication is basically you do the sign-in and the sign-out on your own. I don't care. OIDC can do it sometimes. Facebook, for example, can do sign-in. It can't do sign-out. So I was talking about the fact that we encrypt and we sign things. This is done via data protection. Multiple instances need to share a key store and an application name. So as soon as you're load balancing, you're going to hit that. We will create and we will rotate keys automatically for you, so you are no longer stuck to one static key that you can never ever change, because synchronizing that change across multiple machines via web.config was frankly impossible. We configure data protection kind of like this. The application discriminator is your app name. So we try and figure this out automatically based on IIS metadata if you're hosting underneath IIS, or the application path if that's not available, and a bunch of other stuff. But as soon as you start hitting load balancing, where you can't guarantee that each machine is going to be set up the same way unless you're running Docker, in which case even then it might not be set up the same way, you need to set the application discriminator to be your application ID. So that means if you don't, and applications get different applications IDs, but they're using the same key ring, they're isolated from each other. We do this on purpose. So you could have one master key ring for a machine, but multiple applications, and you don't want application A to be able to decrypt application B's data. But if you set the application discriminator to be the same string, it will all magically work. And then you choose where keys get persisted. In this case, I'm shoving them in a backend server because it's easiest. But there's a bunch of things. You can use Redis, you can use Azure Blob Storage. You can write your own, which is actually incredibly easy. It's just two methods. It's like write a new key and read the entire key ring, and that's it. And then we have a separate way of protecting the certificate. So if you just persist them with no protection, they're in plain text, which is a terribly bad idea. So you can protect them with certificates, or you can protect them with Azure Key Vault, or again, you can write your own. And we can configure the cookies. This is a pain in the backside because you configure different cookies in different ways, and it gets even more complicated with ASP.NET Identity, which I am not covering. Yes. So if you want to set a static expiry, this will expire in 15 minutes, you go to options.cookie.expiration. But if you want sliding expiration, you ignore options.cookie and instead you set it one level up. Options.expire time span and sliding expiration. Do not set both at once, because now you're in an unsupported scenario of we don't know which one will win. It's kind of random. We keep trying to fix this. We still haven't come up with a decent API for it. We have promised to fix it in 3. I don't think we will. And then, of course, I can't break APIs in 3.1 because it's a minor revision. So, you know, this might get fixed in 4. But then again, at the speed we're going, 4 will probably be, and this is now me being sarcastic and not promising anything, 4 could be at the end of the year. There's too much change. It's too fast. So you try security reviewing an entire new version of a framework twice a year. This is why I have gray hair. If you're using cookies, though, there's kind of a problem. Once the cookie is there, it is the sole source of truth. You have written a cookie out, and that cookie is where the identity comes back from every single time. So imagine you have a cookie that has someone's username and their employment status, and they're logged into your intranet, and then they get fired. The cookie doesn't know this. The cookie doesn't change. So in theory, they can keep logging in as long as they have the cookie. So there is a way to cope with this, which is yet another event, because events are everything. Events and delegates, that's what we're built on now. Cookie authentication has the onValidate principal event. It runs on every single request. So you will want to throttle this if you are doing database lookups. So you keep a count and away it goes. And in the cookie, on validate principal, we can either reject the principal, which is basically sign the user out, they've been fired, go away, or we can replace the principal. So if they've been promoted, their login is still good, but we can replace it and change their job title. So they're not logged out, but the user is refreshed and the cookie is rewritten. So here we have a validator. You can see these things all build in each other. And what this validator is going to do is I'm going to keep a count of the number of requests that have come in. And after 5 requests, I'm going to call reject the principal. I'm going to sign out the cookie, and then the user has to sign in again. Not particularly exciting because, of course, this is automatically signing in through Facebook, so you'll see it just takes a little bit extra time. And then we wire it up. Options.events, on validate principal, validate async. So we've got 1, 2, 3. In fact, let's cheat because Facebook puts this in now so we can see things. 4. Oh look, it went through its I'm changing things. 1, 2, 3, 4, and away it goes. So it's done the sign out, then Facebook has signed me back in again. So this is how you cope with ever-changing data on the back end. We also use this in ASP.NET Identity for a concept of a security stamp. So there's a value in the database that we use for a bunch of stuff, and when you change things in the ASP.NET Identity database, we will change that security stamp. Just think of it as a random value or a GUID. So if you change someone's name, obviously their cookies need to be updated. So the ASP.NET Identity Validator runs on every 15 minutes, but you can configure it, and it will log people out and it will refresh their identity. It can also sort of be used to support sign out everywhere. So you could choose to invalidate a bunch of cookies based on whether a user has chosen to sign out everywhere and a value that you've kept in your database has changed. So during the Facebook login, I yanked out some information from the response that comes from Facebook, which is great, but that's not all that useful. For a lot of scenarios, you may want to have someone log in, and you may want to go off to 17 million different databases and pull everything in, which actually is what Facebook does, which makes the GDPR people really unhappy. There is a way to do this via claims transformation. It runs after every single authentication request. Remember, the authenticate async event is what happens on every request where we look for an identity in the inbound request and we create the identity from the rehydrated information. Because it runs in every request, you have to write this in a defensive way. So let's take a look at this. I add the claims transformation service. We made this a service so you can do things like inject database connection strings or other bits and pieces. And then there's a transform async method. And I get a principal that comes in. And then what I'm going to do is I'm going to add a claim that is the date at which transformation happened. So in every single request this runs. So it's going to get updated with every single request. And what I'm going to do is I'm actually going to, just in case it got persisted with this claim in it, I'm going to look for the claim already, and if it's not present, I'll add it, which is what I mean by being defensive. So this will eventually run. So we can see transformed on. If I hit refresh, it's going to run every single time and pull this thing in. So you need to cache your results or throttle this thing or whatever else you want to do to make things scalable, because you don't want to be running off to a database before every single request is then given to your request pipeline. That would be silly and not scalable, or something SharePoint does. Those who saw yesterday's presentation will know how I feel about SharePoint. All right, and then this is the bit that makes me feel really uncomfortable about sharing with you. So, why would you ever want to do this? Well, you want to support BankID, you want to support SAML2P. Maybe you want one for integration testing, and there is a reason there is no documentation for this. It is because we don't want you to do it. The people that need to do it probably should be able to read and understand the source code. That's kind of what we hope. There are documented samples, and those documented samples live in my GitHub repo and not the ASP.NET one. They are my basic auth implementation and my certificate auth implementation, because those are nice, clear examples that most people understand. So if you want to do this, at a minimum, you need to handle the handle event. If you're nicer, you give defaults, options classes, and extension methods, and then for extensibility, you add events. So we're going to show our first authentication handler, or as I like to call it, David Fowler auth, because it's nice and simple, and it's one he can write in demos. And it's insecure and fast, which is what he cares about. That's not entirely true. It's gotten a lot better. He now actually brings up security problems, which is a glorious surprise when it happens, and I do appreciate it. And I say this because he'll probably watch the video. So, it is true, though. So, here is our handler. A query string authentication handler. We will never talk about this again once I'm done, okay? So, here's how our handler gets constructed. You need all of those. There is no other way. I'm going to use the default authentication scheme options, which is where I can provide a scheme name and nothing more. It is likely that your handler will want more options, in which case this needs to be your options class. And then, like I said, we have to handle authenticate async. I'm just going to look for a username on the query string. I am going to create... I feel so bad about this. I am going to create an identity out of it. I'm going to create a claims principal out of it. And then the important thing to do is I'm going to create a ticket. So I create an authentication ticket, which takes the principal plus the scheme name. We get this as a property, so it's whatever you set as the scheme name when you configured the handler. And then I will return authenticate result.success with the ticket. Otherwise, I return no result. There is no fail. Oh, that sounds very Yoda. Because remember, we can have multiple handlers. So there may be another handler that comes along and is able to handle this, which is why it's like, no, I can't handle this. Maybe someone else can. I really can't handle it. I'm doing this one right now. Defaults, well, I just have a default authentication scheme. And then the fun bit are the extensions that you need, which is just a bunch of extensions that are the nice syntactical sugar that we have for adding the query string to the authentication builder. And there are 4 of them. And my suggestion to you is you take something like this, you paste it into your own code, and you do a cut and replace on this bit and your options. And that's it. So, let's run this. So we only have my handler. And because there is no username parameter on the query string, I'm getting unauthorized because I couldn't create an identity. Nothing else could create an identity. Therefore, we're done. This is how it figures out. If everything has said, no, I can't do this, eventually, when we do all the evaluations, we'll go, nope, there's no identity created, therefore it is unauthorized. If there was an identity, it just didn't have permissions, we would go to forbidden because we finally got to there. So if I then go, that, yeah. In fact, let's just make this clearer. No, because I don't want you to look at this sort of thing. So we have hello David Fowler because the username on the query string is David Fowler. Now you know how to write your authentication handlers and you will never ever do it. But everyone keeps asking me how do we do it, so I'll demo it. So here we go. This is the starting point, and then we just override handle. And those are the authentication extension methods. So there are other things you want to do. You'll probably likely want to handle challenge, which is where you send a user to do the login stuff. You can do a sign-in authentication handler. You can do a sign, which supports both sign-in and sign-out. It's all very complicated. Like I say, we kind of hope that the people that are writing this will understand the source code, or at least look at my simple examples. And like I say, this was not a Spider-Man quote to begin with. This was Voltaire, because I am posh and I had a classical education because I grew up in the UK and not the US. I don't know why American people get upset with my presentations. Sodom. So now you know how to write one of these things, but unless you have a really good reason, please don't. So now that I have thoroughly depressed myself by showing you how to do that, we're going to talk a quick lap through authorization and code policies and how these things work and how these things plumb together. So we're going to talk about policies, requirements, and handlers, authorizing everything, how multiple authentication handlers work, scheme selection, and then how we do things differently in MVC versus Razor. And then don't even ask me about the server-side Blazor, because I don't think we've figured that out yet. I really have to do that when I get back. So I'm going to do a quick, simple setup. Okay, bye-bye authentication, go away. So I'm going to use cookie authentication for this because it's simple. We have a login path and we have an access denied path. The login path is where a user would normally type their usernames and passwords, and the forbidden path is like, no, you're a bad person, go away. And that's all I'm wiring up. And of course, app.useAuthentication. And what I'm doing for the purposes of this, in my account controller, I am just not going to prompt for logins. I'm just going to create a user principal. I'm going to sign that user principal in. This is how you do the manual sign-in. You look for HTTP context. You call sign-in async with the scheme that you want to sign in against. You pass in the user principal, and I'm just going to say, no, this isn't persistent, and just generally override things, and then redirect back to where we came from. No, local redirect. Local redirect means that we are going to check that the URL that you are giving us is contained within your application and is not somewhere else that's naughty and bad and providing open redirects, which can lead to phishing. So if I run this, it'll just log in. Basically, it will use that user that I have created. Oh, did I not change the startup project? Oh, I'm an idiot, as you've already realized. And I had said this one to start running through IIS rather than Kestrel, so I would remember, because it would be entirely different. And that just shows how bad my memory is. Okay, so IIS is starting. We've got a different port this time, and it will eventually log me in. IIS has a longer startup time, even though this is in process now in 2.2. So we have hello Barry. Nice and simple. That is our starting point for starting to experiment. This is what we did. Okay, so first of all, we want to authorize everything. We want to authorize every single page on our application because it's safer. Things that need to be anonymous should be opted out of authorization rather than relying on your coworkers to opt things in. I'm sure your coworkers are trustworthy. So we go back to here. I remembered. And the way we're going to do this is inside the MVC config, and this works for Razor too, because Razor is MVC. We're going to build an authorization policy, and it is going to require an authenticated user. And then I'm going to set a global filter, which is an authorized filter that's based on policy. When it boils down to it, everything we do in MVC and Razor ends up as a filter, at least until version 3, and then it gets a little bit more complicated. But this is going to apply the filter to every single request, and everything will be authorized. So if I hit run now, what do we think happens? Oh, Swedish audience, no one ever answers. Obviously, says Barry from the audience in his head, it's going to log in, because it doesn't matter. I'm going to see hello, and because I've applied authorization and I've overridden the login page, and it has an identity, it's going to log in, but it doesn't. We get this. We get IIS request filtering kicking in, which is cute because I keep forgetting that that thing exists. If I then look at return, look at the string, and oh, that's, yeah, okay, no. So I can see why I objected to this. And Kestrel would object to this too, because we put a bunch of request filtering stuff in before I ever let it be exposed on the public internet. And the problem here is we have authorized everything, and everything requires an already logged in user, and that includes our login page. So I can't log in because the login page requires me to be logged in, and so I get this redirect loop. So if we authorize everything, we also need to, oh no, not the view, the controller. Wrong controller. We need to put allow anonymous at least on the login page, but probably the forbid page as well. And now it'll magically work. Hopefully. Because the page that the controller that runs the login now allows anonymous access, so it will run and it will log someone in, and then they can see everything else. There we go. And to prove I wasn't cheating, home controller does not have an authorized attribute on it. It is bare. So our global filter has kicked in and done authorize everywhere, and then I've excluded the login controller from that. And then we come to the new bits for authentication that we did in Core. And to be honest, I am horribly proud of this. This was the first time I got to design a major feature that made it into the framework. I know some of you have problems with it, and if you have problems with it, you're wrong. So, in old MVC, if you wanted custom functionality in your authorization, you had to write custom authorization attributes. And they were horrible and hard to test, and ended up having a lot of mistakes in them from the code that we saw, so you could get around those things due to the code. So we wanted to throw all of that away. All that investment that you made in custom attributes, we threw out the window, and we changed everything, so everything is done in code in policies. Policies are made up of one or more requirements. Requirement may have one or more handlers, and inside the handlers you took the code that you had written for your custom attribute and you shoved it inside the handler. So I'm going to use entering the Microsoft Office as an example here. You have to have a valid employee badge, and you tap your employee badge against the magic door, and the doors swing open. In some of the buildings, it's actually really cool. It then detects people come in after you and fires off an alarm and slams the door closed again, which really hurt when you get hit in the leg with them. So we have an office entry requirement. And then we have to write a handler for that requirement, and our handler is going to check that the user has a badge. It would go further, it would check that the badge is valid, the badge is not from Nintendo rather than Microsoft, all sorts of other things. But we're going to check that there is a valid Microsoft badge. And then I'm going to have a policy for office entry that has that requirement in it, and I'm going to apply the policy in the authorize attribute. So our requirement is nothing. It has authorization requirement, and that is just a marker interface. If you want to parameterize your requirements, you can put properties and stuff in here that you then get inside your handler. But this is nice and simple. Our requirement is just that. And then we need a handler. And so we have an authorization handler that takes our requirement. And we have handle requirement async, because everything is async now. We get a context of what's happening during authorization, and we get the requirement that we're trying to fulfill. So this is where you would be able to get your parameters out. And so what I'm going to do is I'm going to look at the user, which is on the context. I'm going to look for a claim that is employee ID that has been issued by Contoso, because we're not allowed to use real companies in our demos. And if I don't have one, I'm just going to exit out. If I do have the right claim, I'm going to call context.succeed, and that takes back into it the requirement that has succeeded. Okay? And I have changed the identity that I am creating. So now I have an employee ID. So I will immediately pass. There we go. So if I remove this claim, it should fail. I forgot to test this. Yes! All right. This is where I feel like Boris out of GoldenEye every time I go, yes, I am invincible. Okay, and it would also, if I had changed who the issuer of the claim was and said it was Nintendo, it would have rejected it. So on the home controller, I've changed my authorized attribute so it specifies a policy of building entry. And in my startup class, inside add authorization, which we've not had to do before because it was just simple authorization, so we didn't care. But I do services.add authorization, and inside options, I'm going to add a policy. Here's the policy name, and here are the requirements. There's only one, but remember there can be more than one. So it could be office entry requirement and another requirement that said the time is between 6 a.m. and 6 p.m. and then after that, no one else gets in. Which is not true for Microsoft offices. We can be there 24/7 because we care about adding shareholder value. And then the bit that I always forget, after I've added the authorization and set up the policy, we have to add handlers into DI because that's how we resolve them. In this case, because it doesn't do anything interesting, I'm going to add it as a singleton. But of course, if you do take in a database instance somewhere or a repository instance somewhere, you don't want singleton. You want one of the other options. Otherwise, everything's going to go to hell. And that's all we need to do for a requirement. So I'll skip back to this. And where's my handler? Here we go. We see that we have context.succeed if something succeeds, and if something fails, we just return the completed task. If there's a succeed, that must mean there's a fail somewhere. But I don't want you to call that. You don't call that within your handlers. You just call succeed if it's worked. Otherwise, you leave. And we'll talk about why. because people forget badges at Microsoft, and we get this printed out sticky badge of shame that we have to wear, and then you go up to reception and point at the badge and go, "Can you let me in, please?" And the sticky badge is valid for 24 hours. So this is another way to fulfill the requirement, the Office Entry requirement. It's either someone has their permanent badge or someone has a sticky badge that is still valid. So you could just write an enormous handler for this requirement, but that is ugly and untestable and gets away from single responsibility. So you add another handler instead. I have two ways of fulfilling the requirement. Each way gets a handler. So I'm going to skip to here. And this time I have a temporary badge handler, and it's going to look for a different claim, which is temporary badge expiry, which is a date and time, and it will check that it's still valid. And this is why we don't call fail. We don't call fail because another handler for the same requirement may succeed. Fail is there for circumstances like my database is on fire. I know there's absolutely no point for anyone else trying to do something. Just abort out of the pipeline as quickly as possible. It's not there for normal scenarios of I can't fulfill this requirement in this handler, which is what handlers need to indicate. So in this case, I have changed my account controller, and this time I'm doing a temporary badge expiry. So my employee claim has gone. I have a temporary badge claim, and what I have done is I have not changed the policy in any way, but I have added another handler for the requirement. So if I run this, it eventually gets there. And I've been let in with my temporary badge. If I change the account controller so it's -1, so the badge has expired. Actually, let's do -2, just to really prove the point. It should fail if my code is right. Bear in mind, I'm not a developer anymore. I'm a program manager. Oh, there we go. Okay, so it has failed because I have a temporary badge claim, but that badge is no longer valid according to the value in the badge claim. Let's change this back before I publish it up to GitHub when I get back to my hotel. So this is why we don't call contacts.fail. There are two handlers for one requirement. There may be more. So if you can't do something, don't do anything. Just return. So we're talking about multiple schemes. We have different ways of selecting the scheme. So imagine you have cookie auth and you have an API in the same website. Generally a bad idea, I would say, but okay. And so you have JWT for the API. There are multiple ways to choose which authentication handler will run. We can do it in the attributes. We can set authentication schemes. So this one is saying building entry, and I will only accept an identity that has been created by cookie. We can do it in the policy itself. Policy.authenticationschemes.add. And then, because that wasn't enough for you, and because that was the right and clean way to do it in my head, but people wanted to do it based on things like request path, which we told everyone to move away from when we started MVC, which is why we didn't support it in web.config. But no, we now want to do it on path. We can do it with forwarding. Every single handler has a forward selector here, so you can look at whether the path has an API, and then we can say, no, I want to go to API auth. That's the scheme name there. Otherwise, continue with me, which I think is a little bit complicated because you would have to put that on every single handler. Or you can do it with virtual schemes, which is much nicer. You create a virtual scheme. You have the same default select. You have a default selector here that you can actually do your API. You know, I'm in an API path, so I want to pick something else, and then you add authentication with that virtual scheme. So that's nicer to me. Razor does things slightly differently in terms of how you authorize stuff like this. So you can authorize a page, you can authorize a folder, or you can do allow anonymous. You can use the attribute. Just be aware that the attribute applies to all actions on a Razor page. There is no way to choose different authorized attributes for individual actions. That's just a Razor restriction. There are more things coming. I keep promising identity server integration for API projects and for SPA projects. The code is almost ready. I say this every time I give this presentation. It's almost ready. I'm not going to promise months, but we should see it before spring, I would think. In 3.0, we're changing the way authorization works. So authorization now runs as part of routing. So you can apply authorization to any endpoint that you like. So say, for example, you have a health check using the health check API. There was no way to authorize that API before because it didn't support it. But now it's built into routing. It can be applied to anything that ends up with an endpoint, anything that does some sort of output. So you will see demonstrations for that reasonably soon. It's there in the latest drop that we pushed out a couple of weeks ago. It's a little bit heavy in that we discovered a bug that if you configured MVC in certain ways, it wouldn't authorize. So we actually end up running authorize twice right now. That should be fixed in the next drop. So there are labs for all of this. If you want to learn how to write your own authentication handler, and you don't, you can go through the authentication workshop if you want to look at how authorization works, which also goes into resource authorization, where you can pass a resource like a document into the authorization calls, or do weird things in your views. Then work your way through the ASP.NET authorization workshop. All these links will be on my website, which is idunno.org, idunno.org. Give me till lunchtime, and I will have pushed everything, and I will have pushed the GitHub repo for this demonstration, which you will never use because you don't need to write your own authentication handler ever, unless you have weird banking standards. That is pretty much it from me. Thank you very much for coming. I hope you enjoy the rest of your day.